बढ़ो कि दूसरों के लिए रास्ता बनते चलो। जहां से हो सके मुमकिन तामीरे वतन करते चलो।
उजाले ज़मीं के तुम्हारे ही दम से तो है।
उजाले ज़मीं के हमारे ही दम से तो है, उजाले ज़मीं के हमारे ही दम से तो है। ये ज़मीं
University warmly welcome you all to the first International Conference on Energy, Power and Environment in collaboration with the University of Gujrat and UET Texila. We are highly thankful to you all for participating and making this conference a success. We wholeheartedly extend our appreciation to the official partners, Engineering Proceedings, Pakistan Engineering Council, and Journal of Engineering Research. Worthy members, it is mark of our undying tradition to invoke the Almighty at the beginning of every important event. To take the formal inauguration of this event, may I please request Hafiz Muhammad Fahad for the recitation of Holy Quran.
السلام عليكم ورحمة الله وبركاته. أعوذ بالله من الشيطان الرجيم. بسم الله الرحمن الرحيم. الرحمن علم القرآن خلق الإنسان علمه البيان الشمس والقمر بحسبان والنجم والشجر يسجدان والسماء رفعها ووضع الميزان ألا تطغوا في الميزان وأقيموا الوزن بالقسط ولا تخسروا الميزان والأرض وضعها للأنام فيها فاكهة والنخل ذات الأكمام والحب ذو العصف والريحان فبأي آلاء ربكما تكذبان خلق الإنسان من صلصال كالفخار وخلق الجان من مارج من نار فبأي آلاء ربكما تكذبان صدق الله العظيم.
Jazakallah. The most merciful who taught the Quran created man and taught him eloquence. The sun and the moon move by precise calculation, and the stars and trees prostrate, and the heaven he raised and imposed the balance, that you not transgress within the balance, and establish weight and justice, and do not make deficient the balance, and the earth he laid out for the creatures, therein is fruit and palm trees having sheaths, and grain having husk and scented plants. So which of the favors of your Lord would you deny? He created man from clay like that of pottery, and he created the jinn from a smokeless flame of fire. So which of the favors of your Lord would you deny? Lord of the two sunrises and Lord of the two sunsets. So which of the favors of your Lord would you deny? He released the two seas, meeting between them is a barrier, so neither of them transgresses. So which of the favors of your Lord would you deny? Hundreds and thousands of salutations to a Prophet Hazrat Muhammad sallallahu alaihi wasallam. May I please request Mr. Jamshed to do the honors.
न कोई आप जैसा था न कोई आप सा होगा न कोई आप जैसा था न कोई आप सा होगा कोई यूसुफ से پوچھے مصطفیٰ کا حسن کیسا تھا، زمین و آسماں میں کوئی بھی مثال نہ ملی، مولایا صلی وسلم دائما ابدا۔ اور دلیل زندگی وہ ہے، کمال بندگی وہ ہے، دلیل زندگی وہ ہے، کمال بندگی وہ ہے، کوئی بھی دور ہو اس میں مراج آدمی وہ ہے، وہی تو دین و دنیا ہے جو باتیں آپ نے کہیں، مولایا صلی وسلم دائما ابدا۔ درود ان پہ، سلام ان پہ، یہی کہنا خدا کا ہے، خدا کے بعد جو ہے مرتبہ صلی اللہ کا ہے، وہی سرکار عالم ہے، وہی غمخوار امت ہے، وہی تو حشر کے میدان میں سب کی شفاعت ہے، شفاعت کے لیے سب کی نظر ان پہ لگی ہوگی، مولایا صلی وسلم دائما ابدا۔ جزاک اللہ۔
Subhanallah. Ladies and gentlemen, I request all the dignitaries to please stand proudly for the national anthem of Pakistan. Thank you all. I once again warmly welcome our esteemed guest, Dr. Shabir Atiq, Vice Chancellor, University of Gujarat, Dr. Shahid Iqbal, Dean Faculty of Engineering, University of Gujarat, our distinguished guest, Dr. Banab Mari, Universitat Politencia de Valencia, Dr. Fahimul Islam, Rector GIF University, Professor Dr. Muzaffar Ali, UAT Texila, Dr. Muhammad Bilal Khan Niazi, NUST, Islamabad, Registrar GIF University, Mr. Wasimullah Dar, Dr. Aisha Rafiq, Director, Faculty Development Department, all the deans, directors, researchers, and faculty members. So here we are together as a family to mark another landmark of learning, growth, and research at GIF University. GIF University is the only chartered university with a W4 ranking in the region Gujranwala. The university is offering the highest number of degrees with a vision to develop ethical graduates by converting knowledge into practical experience. Before we proceed ahead, I would like to invite the esteemed presence of worthy rector, Professor Dr. Fahimul Islam, GIF University, for the welcome note.
Bismillah ar-Rahman ar-Rahim. Assalamu alaikum. Welcome and good morning. Professor Dr. Shabar Atiq, the Vice Chancellor, University of Gujrat, and the Patron-in-Chief of this conference. Not present here, but we also acknowledge Professor Dr. Muhammad Inayatullah Babar, the Vice Chancellor of UET Texla, and Professor Shahid Iqbal, Chair of the conference. Professor Zayad Nair, our Dean, Computer Science and Engineering at Gift University, Professor Dr. Barnab Mari. Today's keynote speakers, Dr. Muhammad Dahida from Newcastle University, UK, Professor Dr. Muzaffar Ali, UET Texla, Dr. Muhammad Bilal Khan Niazi, NUST Islamabad. Dear professors, researchers, and organizers, welcome to the second day of First International Conference on Energy, Power and Environment, organized collaboratively by University of Gujrat, University of Engineering and Technology, Texla, and Gift University. All three new universities. I had the privilege to witness UET Texla coming out its first buildings and starting as a campus of UET Lahore, where I was an assistant professor at that time in electrical engineering department. I also visited University of Gujrat when it had only one building and others were just being constructed. Dr. Nizam was the vice chancellor. And of course, Gift University, all new universities. But new universities of very important region of Pakistan. I feel very proud and very happy that these universities have grown into large universities in their area, leading universities in their area, and mature to the level to hold this August conference. I attended partially yesterday's speakers. I really was fascinated at depth and breadth of knowledge that was being expressed. It's not easy to organize such a deep technical conference in this region, and I'm very happy that it has happened. And I hope very much that it will become a recurring event every year. Surely the conference is providing platform for sharing high quality research and international professional interactions, tackling the key global and societal challenges of ensuring and provision of energy and protecting our environment for the future at the same time. And it is very meaningful that we have linked these two topics together in one debate and dialogue. The scope of the conference is broad and it recognizes the complexity of issues and challenges relating to energy generation, conversion, storage, alternative fuel technologies, and of course, environmental science. And I wish success for the conference. It is certainly a very brilliant and a brave effort, and not easy to organize such conferences internationally. There's so much of logistics and so much of technology and so much of collaboration that is needed. Hats off to the organizers. Hats off to the three universities. Thank you very much for being here, and welcome again to Gift University.
Thank you so much, sir. May I please now request Dr. Shabar Atiq, Vice Chancellor, University of Gujrat, for the welcome speech.
Bismillah ar-Rahman ar-Rahim. The Honorable Vice Chancellor, Rector, Gift University, Deans, faculty members, our guests from countries abroad, all the participants, Assalamu alaikum and very good morning to you all. It really gives me immense pleasure to see this conference happening, as we had been planning it for about 6 months, and due to various reasons, including prevailing situation, it couldn't happen earlier. Definitely, as Dr. Fahim Saab just mentioned, this topic is really critical and very important. And linking them, energy, power, and environment, is very meaningful as well. I attended yesterday's inaugural session, and I heard Professor Barnab Mari, his keynote address, lecture, and It was really of great interest to me because as I am a materials engineer, so we were talking about new materials and, to harvest the energy in different forms. Joining hands, three universities is a really positive sign, extremely important. And I'm really pleased that two of the public sector universities and a growing big private sector university have joined their hands in organizing this event. And as Dr. Saab said, and yesterday I also mentioned, that let's make an annual event. It shouldn't be one-off conference. And probably we can take on board some other institutes as well, so that the scope of this conference widens a little more and the sharing of knowledge, research translates into some meaningful outputs. I once again congratulate all the participants, especially the organizers, for making this happen. And I wish everybody sitting here well. Thank you very much for having me here. It's really great privilege and honor for me to be here. Thank you very much.
Thank you so much, sir. Before we proceed ahead, may I please take the opportunity to inform you all that these technical sessions are being organized at 4 different on campus venues. May I please have your attention, requesting you all to proceed accordingly. I request the participants of technical session track 7 to please stay here in the seminar hall. Participants of technical session tracks session 7 track 2 are requested to proceed to room G1. Participants of technical session 8 are requested to proceed to room G2, and participants of technical session 9 are requested to proceed to room F2. Before we proceed ahead, may I please request our worthy rector, Dr. Fahimul Islam, to please come forward to present the honors to the chief guests. I also request Mr. Wasimullah Dar, Registrar GIF University, to join Rector Saab to do the honors. I wholehearted request Dr. Shabar Atiq, Vice Chancellor, University of Gujrat, to please come and receive the honors.
Hello, assalamu alaikum.
Please put your hands together for Dr. Shahid Iqbal, Dean Faculty of Engineering, University of Gujrat, to come and receive the honors. I request our distinguished guest, Dr. Barnab Mari, to please come and receive the honors. Please put your hands together for Professor Dr. Muzaffar Ali, UET Texila, to come forward and receive the honors. May I please request Dr. Muhammad Bilal Khan Niazi, NAST Islamabad, to come forward and receive the honors. May I please request Dr. Shabar Atiq to come forward and present the honor to Dr. Fahimul Islam. Thank you, sir. May I please request Dr. Zayad Nair, Dean School of Engineering and Applied Sciences, GIF University, to come forward and receive the honors. May I please request Engineer Dr. Qasim Awais, Head of Department Electrical Engineering, to come forward and receive the honors. I thank you all. I'm profusely elated to take an opportunity to introduce our international keynote speaker, Dr. Muhammad Dahida, Associate Professor, School of Engineering, Newcastle University, United Kingdom. May I please request him to formally take up the session with a keynote speech. May I please request the other participants to proceed accordingly to the respective rooms for the formal session. School of Engineering, Newcastle University, United Kingdom, to please formally take up the session with a keynote speech.
Good morning, everybody. I'm just trying to make sure that you hear me well.
Sir, are we audible?
Yes, I am. I'm just making sure that, do you hear me?
Yes, sir.
All right, thank you very much. A very good morning to all of you. If you give me just 1 minute to make sure that I share my screen as well. So, all right. Hopefully you can see my screen now.
Yes, sir.
All right. A very good morning, and thank you very much for giving me the opportunity, to share my talk with you. It's a shame that I couldn't make it to be there physically, because of all these ongoing restrictions, and it was a short notice as well. But I'm pleased that I'm online as well. I do apologize. It's quite early morning here, but hopefully things will go smooth as well. All right. So to begin with, just let me give you a very quick introduction about myself. I'm Mohammed Dahida. I'm senior lecturer, that's equivalent to associate professor in different categories in Newcastle University. I joined Newcastle University in 2013. But before that, I was with Nottingham University in Malaysia campus between 2007 and 2012. And I was a lecturer in the Faculty of Engineering Multimedia University in Malaysia, and that's between 2002 and 2007 as well. I had my PhD from Malaysia, MSc from Malaysia as well, between 2002 and 2008. And I did my degree in electrical engineering as well in Libya back in 1998. Okay, so just to give you a very brief information about where we are now in the UK. So as you can see, we are in close to the border between England and Scotland. So it's up north, and that's in Newcastle University in the northeast of England. Within the university, so that's the building where I'm speaking to you now. So that's I'm calling you from my office in this morning, and we are within the School of Engineering, and that's actually is a 5 unit school of 5 disciplines that includes chemical, civil, and electrical, mechanical, and marine as well. So we are integrated School of Engineering. The school has went restructuring in the last couple of years. So we were to be an independent school of electrical and electronic engineering, and now we merged together in one big school. And this is one of the leading schools in the UK in terms of engineering. Within the school, we have a different research groups, and I belong to electrical power research group, and this is one of the leading research group in the UK as well. So the group is very large. We are about 16 academics within the group, and we have about 20 research staff and about around 50 PhD students and more than 100 MSc students within the program itself. So we are expertise in different areas of electrical and electronic engineering. We see our strength in power electronics. We do control and drives. We do machine design for different purposes as well, high-speed machines, fault-tolerant machines, etc. And we also do a lot of research in power systems and smart grids and all these aspects. So that's a small pictures of our labs. So that's basically is very quick informations about myself and where we are now. Most of our research is blue sky research, but we also do industry collaborative research as well. So these are just examples of industry that we are engaged with. All right, so let's crack on and start the presentations. What I'm trying to cover in this very quick presentations is around these 5 really topics. So I'm gonna start with a very quick history and what is the market for the EVs, and how the market looks like, what is the forecast for the couple of years to come. And I'm gonna focus more on the infrastructure or the charging infrastructure. I would be more biased towards power electronics, to be honest, because the charging infrastructure is not only power electronics, but the wider picture of that is very huge segments. But as far as the talk of the day concerns, I'll be highlighting more on power electronics. I'll be biased on more power electronics, to be honest. And I will try to share with you some of them commercial available EV chargers, and we will see the difference, and we will see where power electronics lies in this chargers as well. And hopefully we can conclude with some trends and challenges, opportunities, and we can probably signpost towards some of the exciting research or the opportunities or avenues that can be explored for the research as well. I'm not sure about the time, but if I got some time, I will try to highlight some of our activities within the university itself in terms of EV charging as well. All right, so to begin with, electric cars is not a new topic. It has been around 18s, early 18s to the late 18s. Actually, it was there, so it's not something new from scratch. So it started in mid of 80s and then started to develop further. The real EV or the real electric car started in 1890s, and that was actually in the US. It is a small prototype car, if you like, but it achieves actually a 20 mile per hour, and it goes to 50 mile without charging. So that's a big stepping stone for the direction of electric cars. And it started to be developing a bit around early 90s, where the technology is being overcome by combustion engine cars, where it becomes, because the fuel at that time becomes more cheaper, and also the electric components of the EVs were not mature enough, and there were a lot of challenges. So the internal combustion engine outweighed the electric cars, and that's where we see them, the discontinuity of the electric cars. However, in early 16s or between 16 and 70s, where the concern of the environmental issues becomes apparent to the governments, and that's where they start some sort of rebuilding the legacy of the electric car again, because they see the opportunity of reducing the emission and some of the environmental concerns. And that started in the US again, where some cities or states in the US, they introduced what they call the incentives, or some of the regulations to restrict the use of the fossil fuel cars and try to promote the advantage or the benefit of the electric cars. And that's where it really started to crack on. In 60s or 1960s, I think the first General Motor cars was developed, and that's where we had the mass production of EVs. And the first model was EV1, was produced by the General Motors. And then from there are a lot of companies start to tap into this technology, start to develop their own technology in terms of EVs. And around 19s, and that's where the Tesla started to appear as well. And they're trying to achieve a higher power rate. It's also trying to achieve a longer travel distance, etc. So that's where the benefit of the AV start to crack on. And from there, the growth goes very rapidly, where many manufacturers start to look at the AVs as well. And then there are drivers, which I'm going to discuss in the next slide, how the BV or the AVs can become more and more popular or more aggressive in terms of productions, because there are some other drivers which driving this towards the technology. But since 17 onwards, and that's where it becomes the environmental regulations and some of the initiatives from the governments and the car industry taking place, and that actually what makes the progression is very fast. So that's, you know, roughly is the progression from 80s to 2000s or 2020. Now, what is the main driver for electrified transport? It was found that transportations or transport in general, transport sector actually contributes a lot to the CO2 emission. And I think in 2014, it was about 1/4 of the emission comes actually from the transport. And 75 of this 1/4 came actually from the road transport. So it is apparent, it's important now to deal with this transport or the producer of the CO2 emission, and it's tailored up with a lot of initiatives from the government, from the policymakers, so to make because they have a target, they have a binding targets to achieve by 2050 or by 2070, depends on what sort of a consortium you are. So in order for them to achieve this target, so they need to think about how to electrify, or in other words, how to reduce the emissions produced by the road transport. And that's where we see the technology start to bomb up. So it's about 75 of the road of transport sector is coming from the road transport, and that's it really makes sense to think about electrifying the transport in that sense, and that becomes like a driver or a pusher for electrification of transportation. If you look at the global market, how this is being developed, so over the years, I think especially from 2012, 2013 onwards, so we see a lot of different cars. So the AV becomes more and more familiar on the streets, and we have a different type of cars we can see on around us. But the progress is surging very fast, and the trend is going up very fast, really, in the last couple of years. So if you look at the global market, and especially in 2020, the last year, really, so despite all the pandemic and all the COVID-19 impact on the economy, but in AV sector, it has seen a rapid growth in terms of AV registration. So in 2020 alone, there were around 10 million car registered globally, for 2020 alone, and it is spread out around the whole world. But there are regions where this progress is obvious, and China being one of the leading countries in deploying the AVs. But in 2020, really, Europe overcome this, and there were 1.4 million cars registered in Europe alone in 2020. And China were, I think, around 1.2 million as well. And the point I'm trying to highlight and here really is the trend that we can see in the EV registrations, and this trend actually continues to be rising as well. So if you look at, for example, the data for 2021, the first quarter shows actually 140% rise as compared to the same period in 2020. So you can understand from this, the trend is really going up very quickly. And according to the Sustainable Development Strategy, so the suggestion, if things went fine or went well as a plan for the 2070 target, where all the transport becomes an electric transportation. So in that trend, so we are expecting to see 230 million global EV by 2030, and there are more. There are different initiatives trying to drive or to achieve this. So there is, for example, a consortium called AV 3030. So that's again, there is a private sector is driving this. There is also government restrictions driving this as well. Okay. Why the AV becomes more and more apparent, or becomes more and more accepted by the consumers? So there are different enablers for this technology. So it started from the stringent government regulations to reduce the CO2 emission, and the battery technology becomes cheaper, becomes more powerful. So that means the anxiety of the range becomes less and less from the consumer point of view, because that was the first barrier to kill actually the EV market. Actually is the range anxiety, and they need to be competitive with the existing internal combustion engine cars in terms of the range, in terms of the charging as well. So there are a lot of development, there are a lot of growth in terms of the technology, and these help actually to increase the acceptance or the uptake of the AVs globally. So government regulations in one side, the development in the technology, for example, in the battery technology, the driving range now becomes more and more acceptable for the consumers. So for example, if you look at the 2020, the average EV was about 350 kilowatt, which is 350 kilometer range, which is up from 200 in 2015. So you can see there is a progress in this, and that actually convinces people to uptake the EVs and also to participate in this growth as well. On the other side of the spectrum, you can see that there is an integration as the demand on EV grows. So of course the demand on the energy will grow as well. So that opens another opportunities to integrate or to utilize more on the renewable energies integrations, and also because there will be a demand for charging as well. And also this will be seen as an opportunity with the modern electric grid in terms of balancing, because all these renewable energies are fluctuating resources. So we need to maintain the baseline, if you like, and also you need to regulate the power flow within these energies. So AV is seen as an opportunity in that dimension as well. The charging infrastructure, which we're going to highlight today in today's talk, also this is another pusher for another enabler for uptaking the AVs as well, which has developed a lot. So we have a variety of charging options, if you like. So from home charging or on domestic charging on the streets, you have the fast charging on the highways or motorways as well. So all these are factors help actually to promote the AV wider. Okay, so that's it, a kind of an overview picture on the AV and how the market is looking like. I'm gonna dive into the EV charging infrastructure in this case. So if you look at the revolutions in the past, so that's what Thomas Edison charging station in 1889, and as you can see now, the current and the future charging infrastructure will look like something like this. So you can see there's a tremendous change in the development of the technology, and this actually is not only in one sector the improvement is there, but that's actually owned by the communication by the power electronics, by the resources, by the energy, by the materials. So all these actually help to develop the technology further. If you look at the wider picture in terms of infrastructures, again, I'm just going to emphasize again, the talk will be more tailored towards power electronics. But if you look at the wider picture of the infrastructure, it's not only power electronics. Of course, power electronics is the main or the backbone of these components within the wider infrastructure, but it's not only power electronics there. And it also involves some sort of control, some sort of the civil or the mechanical aspect of it. Looking there, you're going to see some sort of communication between the distribution provider or the power network and the charging points, and depends on the charging stations themselves where you charge your car. Is it plugged into your house, or you are plugging to the off-street chargers, or you are charging from motorway stations? So there are different aspects to look at from the charging infrastructure point of view. But what I'm trying to highlight in this talk, I'm trying to focus more on power electronics. I'll try to highlight the importance of power electronics in developing this charging infrastructure. Now, if I try to categorize these different aspects of the charging infrastructure, so you will see there's the power conversion involved. The energy storage, that is a fundamental component in charging structures as well. And if you look at how we supply or how we charge these EVs, so it depends on the location, depends on the utility grid that is connected to the chargers or providing the energy to the chargers. And there will be some sort of communication between the supply and the battery and the cars, etc. So there will be a control and software involved as well. The communication protocol, how you charge your, how and when you charge your vehicle as well, that is important aspect of the charging infrastructure. The connecting devices or the charging devices, if you like. So that depends on the type of car, depends on how you charge your car. So that's, again, it has some sort of different variation in terms of devices and standards, if you like, as well. So these are the main, if you like, the main components of the charging infrastructure. But I will be focusing more on power conversion for this talk. And we will see how this power converters actually, or power electronics, has developed or has enabled actually the technology to develop further and further. Okay, now looking at kind of more zoom picture in terms of the charging infrastructure. So you will see there a different type of charging modes. So you either charge your car from, the home mains, which is, it could be 110 volt or 220 volt or 240 volts. Also you charge your car wirelessly. So there's an inductive charging as well there. So that's another technology to look at. Or you charge your car from high power chargers, which is normally in terms of DC chargers. So in general, there are three modes of charging, and normally they call it level 1, level 2, level 3, and there are some other classification, they call it mode 4 as well. So normally level 1 is an AC charging, and that's normally between, it depends where you are and what type of energy you have. So it's either 110 supply or 240 supply AC. And this is normally the slow charging, where you can charge over the night. You plug in your car over the night and you can charge your battery, and then in the morning you get your car ready to drive. There is another level that is a semi-fast charging. So the first one called the slow charging, and this is a kind of a semi-fast in between the charging mode. And that's normally, it could be a single phase and three-phase system as well, and depends on the charging power. But this is roughly is around maximum 22 kilowatt power. The third mode is the fast charging, and this becomes more and more appealing for the wide acceptance of the AVs, or the driver actually to uptake the AVs. And the reason why, because consumers are more concerned about the charging time, and if you don't make your AV competitive with the normal gasoline or combustion engine cars, so people don't bother about the environment so much. So because they need to to charge their car relatively in the same time. So that's where the infrastructure of the charging, or the charging infrastructure, plays an important role to drive the technology forward. And there has been a lot of research, a lot of trials in terms of the fast charging in the last couple of years. And I'll try to share with you some of the commercial available examples as well as we go on with the presentation. But that's roughly the range or the modes of charging for AVs. And again, all these charges or charging modes, they require different connectors to plug into your car. And different connectors means we have a different charging protocol and different standards as well. So so that's one of the obstacles, if you like, still need to be addressed, is the the harmony between these different charges. People, they get confused whether my car can be charged using this plug or that plug, or I can use fast charging, I can use slow charging. So there must be some sort of standardized standards or protocol, which again, that's one of the obstacles in terms of widespreading of the AVs. Now, looking at this, this is just a kind of illustrative example of the role of power electronics in this area. So you can see there's an onboard charger here that, some sort of, in one way or another, there's a power electronics components involved in that. And within the car itself, there are subsystems that requires a different level of voltages and different level of power. So that's where we see, again, the power electronics impact in this spectrum as well. So you either need to charge your battery, and you need to drive your car, or the traction or the inverter traction, that also which is a form of power electronics. And there are some auxiliary circuits on your car as well that requires a different type of power, different voltage levels. So again, you need to step down the voltage in various forms. So these converters, they might need to be a bidirectional converters as well. So you need to have the power flow from one side to another. And we're going to highlight a bit on this as we go on as well. Now, the classification of these charges. So as I said, there is an onboard chargers, there is an offboard chargers. So for the onboard chargers, there is a dedicated AC chargers. So that could be level 1 or level 2. And that, for example, if you just plug in your car to the home charger or to the home mains or the plug, then there will be an onboard charger that actually charge the battery. So this is, of course, is the slow chargers. There is an integrated chargers as well. And the reason behind this, or the motivation behind integrated chargers, really is to best utilize the equipment on the car. Of course, when the car is stationary, is not moving, so basically the traction inverter is not in use. So if we could use that converter to charge the battery while the car is stationary, that would be a big advantage in terms of cost, in terms of the size and the volume of the equipment on the car itself. There's also auxiliary chargers, which, as I said, your battery might be 48 volt or whatever the volt is, or the modern cars now is 400 volt batteries, so or 350 volt batteries. But there are some appliances or some applications in your car that only requires 12 volt. For example, if you want to charge up your phone, so it's only 10 to 12 volt or 15 volt DC, then you need to step down the voltage. So there are some other converters involved there. So for the off-board charger, this is normally from medium to high charging rate. So again, there's an AC charger. Normally, this is a 3-phase system. but it's more now on DC chargers. That is what is more attractive, and that's where the development is being seen or being looked at for the recent years. Other type of charging systems, which is a battery swapping, where it's there is a mechanism actually to swap the battery in one sense, that you just plug out and plug in the batteries, and then you pay for the charge or whatever it is. So that's one way actually to charge your battery or to get your car moving on. There's also a very high trend in recent years. When I say recent years, really is a couple of years, last couple of years, 2 or 3 years, on wireless charging. Again, as a technology is not new, but it is a very promising technology for the EVs and for the growth of the EV as well. So this wireless charging there is a stationary and dynamic wireless charging. So I'll try to highlight a bit on this if you got time at the end of the presentation. But that's one way to charge the battery without any interfering from the driver itself. So you just park in your car, and then the car will be charged. Or there is a dynamic, which is in it's kind while you are moving, where the car in motion, you can also charge your car as well as the car moves. Okay, so talking about power electronics, so there are a lot of different topologies or candidates, if you like,